the first question is to find all 6 trigonometric values of the angle alpha equal to 4 pi over 3. So we want to find sine of alpha, cosine of alpha, etc. And also mark the appropriate location of the angle in the coordinate system. So 4 pi over 3 is a little bit more than pi, right? It's 1 whole pi plus another pi over 3. So this would be an angle of 4 pi over 3. And we can even also see the reference angle because we're going to want to know the reference angle. The reference angle here is going to be pi over 3. So if I was finding the trig functions of this angle, I would draw the triangle for pi over 3. Or if you prefer, you can say, oh, I know that's 60 degrees. And in the 30, 60, 90 triangle, the side that's opposite the 30-degree angle is the smallest side. The hypotenuse is the biggest side. And the side that's opposite the middle angle is the middle value. That's how I always think about it. So if I'm trying to find sine of 4 pi over 3, well, I know sine of pi over 3 is going to be opposite of hypotenuse. It's going to be square root of 3 over 2. And then I know there's a sine issue, S-I-G-N sine issue. I'm going to fix that at the end. Cosine of pi over 3. I know I'm writing 4 pi over 3. Cosine of pi over 3 would be adjacent over hypotenuse, which is 1/2. And tangent of pi over 3, even though I'm writing 4 pi over 3, tangent of pi over 3 would be square root of 3 over 1. Now you see I left some space. That's to adjust for the sine. We're over here in quadrant 3 where tangent is positive and the other two are negative. And then we do the reciprocals. The reciprocals all keep the same sign. So cosecant of 4 pi over 3 is going to equal negative 2 over root 3, which we should definitely rationalize as negative 2 root 3 over 3. And secant of 4 pi over 3 is the reciprocal of negative 1/2, which is negative 2. And cotangent of 4 pi over 3 is the reciprocal of root 3, which is 1 over root 3, which we should also rationalize and get root 3 over 3. Do please feel free to chime in if you have questions. I'm just going to kind of keep going, but if you have a question or a comment or a concern, tell me. Say things or write in the chat. And I'm definitely keeping an eye on the chat and not covering it up like I sometimes not so smartly do. So yes. He says he's about to kind of.
I have a quick question.
Go ahead.
Would you require that much like showing our work for?
No, I would require not very much work shown really at all. I did, it does specifically ask you to locate the angle, so you do have to show that. But no, I mean, if you are finding these values a different way, that's also fine. I would encourage you in general to err on the side of showing more work than less. Because if you, for instance, if you wrote all the values down and didn't show any work and you got some of them wrong, it's harder for me to award partial credit. Whereas if you have shown work, I can see maybe where you made an error. It's easier for me to be like, oh yeah, they knew what they were doing mostly. They just kind of messed up this one little part most of the points. So typically, for a lot of people, showing work is usually a good way to get more partial credit if the answer is wrong. Let's look at number 2. So we were given that sine of theta equals negative 12/13 and cosine of theta is greater than 0. Before I even look at the rest of the problem, actually, I take that. Let's ask anyway. Based on this information, what quadrant is theta in? Theta must be in, let's see. Sine is negative, so it can't be up here or up here. Cosine is positive, so it can't be over here. So theta's got to be in quadrant 4. Not that we're being asked that, but it's always good to think about. So then the question really is, what quadrant is 2 theta in? Okay, so this is, I wouldn't say this is a trick question, but it's a question that requires you to do some thinking about what you, well, in fact, I even write it here. You will need the double angle formulas to find sine of 2 theta and cosine of 2 theta to determine the quadrant. So I thought I was trying to be tricky, but I was like, no, I'm not trying to do it. All right, so we want to find sine of 2 theta and cosine of 2 theta. And really, we don't actually so much have to find the values, although we're going to. We just have to determine whether or not sine and cosine are positive and or negative. So we're going to use the formulas. And I don't typically give the double angle formula just because, I don't know, it's something that we've come to expect students to memorize, I guess. I'm not really sure why I don't give it, to be honest. So sine 2 theta is 2 sine theta cosine theta. That's 2 times, well, we know sine theta is negative 12/13. Oh, we need to find cosine theta. So I'm going to draw a triangle. So if you're ever given sine of an angle or cosine of an angle, or tan, right? If you're given a trig function of an angle equal to a value, and you're being asked to find another trig function of that angle, it typically means you want to draw a triangle. So here's my triangle, my right triangle. Here's my angle theta. And sine of theta is negative 12/13. You know me. I like to ignore the negative sign, although you can certainly write it in there if you want to. Either way, it's not going to affect finding this third side. Because you could either say, I'm kind of making a mess here, x squared plus 12 squared equals 13 squared. Or you could say x squared plus negative parentheses 12 squared equals 13 squared. And either way, you're getting the equation. We're just getting x squared plus 144 equals 169. So the x squared equals 25. So the x equals 5. So the cosine of theta is positive, and it's positive 5/13. And then we would calculate this, although really, I mostly cared about the fact that it's negative. So it's a positive times a negative times a negative. Sorry, a positive times a negative times a positive, which is negative. And specifically, let's see, the denominator is 169, and the numerator is 5 times negative 12 times 2. So it's going to be negative 60 times 2, which is, you know what? 2 times 5 is 10, and 10 times 12 is 120. So negative 120 over 169. Find cosine. So I always do cosine of 2 theta as cosine squared theta minus sine squared theta. It's just my jam, right? That's how I do it. It's always where my brain goes. You obviously are welcome to use any of the other formulas. And in this one, it might make sense to instead use the formula that cosine of 2 theta is equal to 1 minus 2 times sine squared of theta. Right? If we were already given sine, we didn't want to find cosine, although we need to find cosine for this one, but you could do that. Either way is correct, right? Whether we do it this first way, cosine of theta is 5/13, so it's going to be 5/13 squared minus sine of theta, which is negative 12/13 squared. Do be careful here. It's easy. Why isn't the 5 negative? Good question. The 5 isn't negative because we were given the cosine of theta is positive. So when I find cosine of this angle, it's got to be positive, and it happens to be 5/13. Usually when I draw this triangle, I completely ignore the signs, and I just put in the signs based on what I've been told. I've been told that sine is negative. I've been told that sine of theta is negative. I've been told that cosine of theta is positive. So that's where I'm getting this being negative and this being positive. But it's always going to be told to you in this kind of problem. So someone's always going to say sine is positive or negative and cosine is positive. They'll give you one of the values. So you can do it all based on that and not have to think about drawing the triangle in the right quadrant. But you could also, not that I do this, right? But you could, since we found out, not that we needed to, but we found out the angle was in quadrant 4, you could draw the triangle in this quadrant and then be like, oh yeah, it's a positive 5 and a negative 12. That's another correct way of doing it. That's a good question. I would encourage you not to use your, so you can do whatever you want. That's the real answer. No one is policing you. You have the freedom to do what you will. There's not going to be true necessarily in future classes. But what I want to say is, I would encourage you to do as much of the final from memory as possible, because classes in fall are going to be in person, and you're actually probably going to have to take tests where you don't have your resources available to you. I don't care which way you do it, but I want you to prepare yourself for what's going to be the situation in, right? Going back to the normal way we used to kind of do things. So it is probably likely that your classes will not give you open book tests. I could be wrong. People might give you take home finals and just make them super hard. So just be aware, right? Like it could be either way. So my wife just got home. Yeah, I'll probably provide the same sort of formulas I did last time. So not the double angles, but all the other stuff. That's typically true. Yeah, Yanquin. So sorry, not to call you out, but that's a good comment. Typically, unit circle is not allowed. Although what I have often provided to students in person is a blank unit circle that they are welcome to fill out for themselves if they want to once the test begins. That is something usually most people will give you if you're in a class where it makes sense to have that. Anyway, back to this. These are good questions. Keep them coming if you have more questions, for sure. Not to stop you, I just want to keep going with this. So 5 over 13 squared is 25 over 169 minus, and then it's minus, this thing squared is going to be positive. So it's minus positive 144 over 169. 25 minus 144 is negative 119. I think, yeah, that's right. So based on the fact that sine of 2 theta is negative and cosine of 2 theta is also negative, 2 theta must be quadrant 3, where sine of it and cosine of it are both negative. Also, just to point out, we could have done it this way, and we could have said it's going to be 1 minus 2 times negative 12 over 13 squared. And then that's going to be, some math. We need a common denominator of 169 over 169 minus 12 squared to 144 times 2 is 288. This doesn't seem easier, but you could do it this way. And then 169 minus 288 is 119, negative 119. So either formula you use, as long as you're using it correctly, should get you to the same spot. All right, let's look at problem 3. You can expect the actual final to be extremely similar in length and content to this practice final that we are going over. Evaluate the following. You need to use the angle sum formula as well as the half triangle formula at least one time, which I have not provided, but you are welcome to look up in your notes or my notes in class. So there you go for the angle sum formula. You're welcome to use it as you will. I will remind everybody, like the angle sum formula for sine of A plus or minus B is sine A cosine B plus or minus cosine A sine B. And the sign here, right, if it's a plus here, it's a plus here. If it's a minus here, it's a minus here. Whereas the cosine formula, cosine of A plus or minus B is cosine of A times cosine of B, and then it's a minus plus. Meaning if it's a plus here, it's a minus there. If it's a minus here, it's a plus there. And it's sine of A times sine. So yes, you are welcome to access those formulas in whatever way is most easy for you. So yeah, so this problem says you'll need to use the angle sum formula. This will as the half angle formula at least one time each. But not for this first one. Secant of 5 pi over 3. So that's just a regular angle we know how to deal with. 5 pi over 3 is in quadrant 4. The reference angle is pi over 3. So I know that cosine of pi over 3 is going to be positive 1/2. So secant of 5 pi over 3 is going to be positive 2. Okay, so the reciprocal, and since we're in quadrant 4, cosine is positive, so secant is also positive. Okay, no big deal. Let's look at sine of the next one is sine of 5 pi over 4. So here the reference angle is pi over 4. And I know that sine of pi over 4, like cosine of pi over 4, is the square root of 2 over 2. So now we're trying to figure out what quadrant we're in. So 5 pi over 4 is in quadrant 3. Right? Because pi over 4 is in quadrant 1, 3 pi over 4 is in quadrant 2, 5 pi over 4 is in quadrant 3. So sine of 5 pi over 4 is going to have to be negative root 2 over 2. All right. Look at the next one. As usual, if you hung up taking the test or have any issues or questions, you're certainly welcome to reach out to me. Email is probably best. Let's look at this next one. Cosine of 11 pi over 12. So having a something pi over 12, that 12 is a really good indicator that we need to use an angle sum formula. But before we can use the angle sum formula, we have to write the angle as a sum of two other angles. So I'm going to write this as cosine of, I'm going to break that up as 2 pi over 12 plus 9 pi over 12. You just have to pick two fractions that reduce. So it would also be correct to do it as 3 pi over 12 plus 8 pi over 12, because they still add up to 11 pi over 12, and they both reduce to fractions with smaller denominators. So this is going to be cosine of 2 pi over 12 is pi over 6, and 9 pi over 12 reduces to 3 pi over 4. And now we're going to use the angle sum formula. That's going to be cosine of pi over 6 times cosine of 3 pi over 4. Plus here means it's a minus here for the cosine formula. That would that would also be that. I think we'll do it that way too. I think that, let's see. Let me double check in my head if that's right. 5 pi over 4 would be 15 pi over 12 minus pi over 3 would be 3 pi over 12, 4 pi over 12. Yeah, that should work as well. That totally works. Yeah, we'll do it that way too, just to show everybody. So sine of pi over 6 times sine of 3 pi over 4. So doing it this way, cosine of pi over 6 is going to be root 3 over 2. Cosine of 3 pi over 4 is going to be a root 2 over 2, but it's going to be negative because it's in quadrant 2. Minus sine of pi over 6 is 1/2. And I always remember that cosine and sine of a pi over 6 or a pi over 3, one of them is always root 3 over 2, and the other one is always 1/2. And it goes back and forth depending on the pi over 6 or pi over 3. And then sine 3 pi over 4 is going to be positive root 2 over 2 because it's the quadrant 2. So then root 3 over 2 times negative root 2 over 2 is going to be negative root 6 over 4 minus root 1 times root 2 over 2 times 2 is 4. So we end up with negative root 6 minus root 2 all over 4. And for these angle sum problems, your answer should always look like something with a root 6 plus or minus something with a root 2 all over 4. if 1/2 was, yeah, if this value ended up being a -1/2, you'd have a negative, and it would be positive. Yeah. Someone asked if 1/2 was negative and the sign changed to positive, and it would. So then it'd be a -√6 plus √2 all over 4. And then somebody else asked, why is it a minus and not a plus? I'm assuming you're talking about this minus sign here. And that's because for the angle sum formula for cosine, the sign in the middle switches. So if it's a plus here, it's a minus here. And if it's a minus here, it's a plus here. Whereas for sine, the sign, the SIGN, stays the same. If it's a plus here, it's a plus here. It's a minus here, it's a minus here. So cosine, it changes, sine stays the same. So the only time I really use an angle difference formula is if it happens to be something like pi over 12. Because pi over 12, I usually going to write as like, what's 15 degrees? I'm going to write it as like pi over 3 minus pi over 4. Because that's 4 pi over 12 minus 3 pi over 12. Usually I don't use the angle difference formula, so I really have to. But someone did ask, could we do it this other way? And you totally could. You could totally write this as cosine of 15 pi over 12 minus 4 pi over 12. And both of those reduce. So then it would be cosine of 5 pi over 4 minus pi over 3. And then we would use the angle difference formula. So it would be cosine of 5 pi over 4 times cosine of pi over 3. And now since it's a minus here, it's going to be a plus here, right? Because for cosine, angle sum formula or angle difference formula, it's always going to be a change in the sign. And then it's going to be plus sine of 5 pi over 4 and sine of pi over 3. Okay. 5 pi over 4 is in quadrant 3. So sine and cosine both going to be negative √2 over 2. We get a negative √2 over 2 times cosine of pi over 3 is positive 1/2. And if cosine of pi over 3 is 1/2, and sine of pi over 3 is √3 over 2, right? Those values always go together for cosine and sine. And then sine of pi over 4 is also a negative √2 over 2. So I get the same answer. I get a negative √2 all over 4 minus a √6 all over 4, which we can simplify as negative √2 minus √6 over 4. And it doesn't matter which order they're in, if they're this, when they're like, as long as you have the correct sign of each of them. It doesn't matter if it's negative √6 minus √2 or negative √2 minus √6, same thing. So yeah, either way would be fine. Let's look at the next one. So just like something pi over 12 is a good indicator that we have to use the angle sum formula or angle difference formula, something pi over 8 is a good indicator that we have to use the half angle formula. So we're going to do sine of 3 pi over 8. And the half angle formula for sine is that sine of theta equals plus or minus the square root of 1 minus cosine of 2 times theta over 2. The only difference between the formula for sine and the formula for cosine is that if it was cosine of theta, it's plus or minus the square root of 1 plus cosine of 2 theta all over 2. That's the only difference though. So if I want to find sine of 3 pi over 8, I'm just replacing theta with 3 pi over 8. So first of all, what quadrant is 3 pi over 8 in? 1, 2, 3, or 4? Yeah, definitely 1, right? It's less than pi over 2. So it's definitely in quadrant 1 or 2 though, right? Because it's certainly less than pi, which means sine is going to be positive. So sine is going to be, it's not going to be plus or minus, it's going to be the plus and not the minus. And your job when you do the half angle formula is always to decide, oh, is it actually positive or is it actually negative? And then it's gonna be 1 minus cosine of 2 times 3 pi over 8 all over 2. That's gonna be positive square root of 1 minus cosine of 2 times 3 pi over 8 is 3 pi over 4. And cosine of 3 pi over 4 is negative root 2 over 2. Again, that angle is in quadrant 2. Cosine's negative. That's going to be positive square root of 1 minus negative root 2 over 2 all over 2. And then there's some simplifying that I do expect you to do. So it's going to be a square root of 1 plus root 2 over 2 all over 2. And then we multiply the top and bottom inside the square root by 2 over 2. So when we distribute this here, we get 2 times 1 and 2 times root 2 over 2. So it's going to be 2 times 1 is 2. And 2 times the square root of 2 divided by 2 is the square root of 2. Divided by 2 times 2 is 4. And then lastly, the square root of 4 is 2. So we rewrite this very carefully to make sure that we're writing the square root just in the numerator. It's the square root of 2 plus root 2, and then all divided by 2. But that 2 has to you have to make sure and indicate very strongly that 2 is no longer under the radical. It's just in the denominator, free and clear of the radical. And again, you are welcome to use your notes to look those up. I think I decided when I was writing the test that they didn't fit very nicely on the page. So. All right, let us look at the next one. Graphing stuff. Okay, cool. Graph y equal to negative 3 sine of 2x. Labeling important points along the x and y axis. Okay, so we know a few things. We know this is flipped. We know that the amplitude is 3. And we know that the period is, what is the period if it's sine of 2x? Well, it's something you eat for dessert. Not 2 whole pies, but 1 whole pie. I mean, who's eating a whole pie? No one. Okay. It's pi, right? The period is 2 pi divided by the coefficient of x. So that thing right there, come on, pens. That number right there is what's going. Well, it depends on the pie, right? You could have a small pie. That's a good point. No judgment, right? Totally fine to eat a whole pie. Even if it's big. I guess I ate a whole pie for the 4th of July 2 years ago for a pie eating contest with my nephew. We all won. I had a lot of pie in my face. Okay. Anyway, I ate that whole pie, but it was like this. I don't know. It's really good pie. Okay. Anyway, back to that. So periods pi, amplitude's 3. It's flipped. And then we know we're going to break up that period into 4 equal quarters or 4 equal quadrants. And so I'm going to do 1/4 of my period. So this one's not hard to find the numbers really. 1/4 of my period is just 1/4 pi. So my x values are 0. And I like to give these subscripts, but you can do whatever you want. The x values are going to be 0 and then 1/4 of pi and then 2 pi over 4 and then 3 pi over 4 and then 4 pi over 4. And there's my 5 important points, breaking it up into 4 equal quarters. So, there. 5 over 4. You can reduce that to pi over 2 if it bothers you to write 2 pi over 4. I do need you to put these, you don't have to write 0, right? We all know where the origin's at. but I do need you to write these 4 points and maybe the fifth one if it's not the origin, although it will be the origin. And then we need to go up to a height of 3, down to a depth of -3. Sine starts in the middle. And then we'd usually go middle, top, middle, bottom, middle. But since it's flipped, it's going to go down to the bottom, back to the middle, then to the top, and to the middle. When you're graphing either sine or cosine, it's important to remember that every other point should be in the middle. So middle, bottom, middle, top, middle, bottom, middle, right? It's always every other point. You're not going straight from the bottom to the top. You have to stop at the middle first. Okay, let's look at the next one, which is cosine of something. Erasers, where are you hiding from me? So let's see, looking at graphing 2 cosine of 4x over 3 minus 1. And here it's important to recognize that the coefficient of x is 4/3. So the period is going to be 2 pi divided by that coefficient 4/3. And I can't stress enough that when you do this division, when you're simplifying it, you have to flip and multiply by the denominator, right? For some reason, I've seen this turn into multiply. People are like, oh, it's 2 pi times 4/3. It's not, it's 2 pi times the reciprocal 4/3, which is 3/4. That's going to be 6 pi over 4, which we can reduce to 3 pi over 2. So there's our period for this one. Also, our amplitude is 2, and our vertical shift is down 1. So if I was going to start graphing this, start laying out what my graph's going to look like, my period's 3 pi over 2. And then I'm going to be going down 1. So my new middle is going to be like -1, like that. And I think it's perfectly fine to draw that dashed line. And then my amplitude is 2. So I'm going to be going 1, 2 above the middle and 1, 2 below the middle. I don't really care about any other y values, just the top, the middle, and the bottom y values. I do need my other x values though. So I'm going to take my period and do 1/4 of it. So 1/4 of my period is equal to 1/4 of or times 3 pi over 2. Fractions times fractions, we're going to get 3 pi over 8. So each of these is going to be 3 pi over 8 apart from the next one. So the first x value is going to be 0. The next one's going to be 3 pi over 8. The next one's going to be 3 pi over 8 plus 3 pi over 8, which is 6 pi over 8. Or 3 pi over 4. Next one's going to be 6 pi over 8 plus another 3 pi over 8. 9 pi over 8. And last one's going to be 9 pi over 8 plus another 3 pi over 8, which is 12 pi over 8, which does reduce to 3 pi over 2. 1, 2, 3, 4, 5, we're good to go. I don't think you need to write them here and label them here. I'm just doing it because I don't know, that's what I do. There they are. Cosine starts at the top. So it's be top, then middle, then bottom, then middle, then top. You should only be getting y values at 1, -1, and 3. You should not get any y values on the x-axis, or at least none that we specifically point out. And you are going to get crossing the x-axis. We are just not really making note of those y values. That's how we graph that one. All right, let's look at the next one. Solving some trig equations. So we're solving 2 cosine of x plus 1 equal to 0. So we're going to isolate our trig function since there's only one of them. So 2 cosine of x equals -1. Cosine of x equals -1/2. So I want to point out, oh, and our answers are between 0 and 2 pi. So with this kind of expression, right, we're going to have 2 answers, right? Even though you might think x is going to equal the inverse cosine of -1/2. Well, that's not wrong. The inverse cosine of -1/2 is 2 pi over 3. This is not the same as this exactly. This is a function, we want one output. This is an equation, we want all the solutions. So here, my solutions are both 2 pi over 3 in quadrant 2 and 4 pi over 3 in quadrant 3. Those are the places where cosine, those are the places between 0 and 2 pi where cosine of x is equal to -1/2. Okay, so looking at this other equation, the second one, we have cosecant squared of x minus cosecant of x minus 2 is equal to 0. And the instructions say you have to factor. And if you wanted to, you could do a u substitution here. You could say, oh, James, I'm going to let u equal cosecant of x. And then u squared is going to equal cosecant squared of x. You don't have to do this, it's totally optional, but you could rewrite this as u squared minus u minus 2 equal to 0. And then maybe it's easier to see that it factors. It factors as u minus 2 times u plus 1. So then I'm going to end up getting u equal to 2 or u equal to -1. And then I can replace u with cosecant. So that means I have cosecant of x equal to 2 or cosecant of x equal to -1. And I will be honest, I never remember what angles cosecant is equal to what at. I'm really going to think of this, well, if cosecant is equal to 2, then its reciprocal sine is equal to 1/2. Because if sine is 1/2, then cosecant is going to be 2 over 1. And similarly here, if cosecant is equal to -1, sine is going to equal the reciprocal of -1, which is also -1. So now I have to find the places where sine is equal to 1/2, which is going to be when, well, I always like to use my previous work if I can. I know that cosine of 2 pi over 3 is 1/2. So cosine of 2 pi over 3 is -1/2. Cosine of pi over 3 is 1/2. So pi over 3 is the angle where cosine is 1/2. Pi over 6 is the complementary angle where sine is equal to 1/2. So the angle here is pi over 6. Or in quadrant 2, 5 pi over 6. And then where is sine equal to -1? Well, that's going to be a quadrantal angle. Not here, not here, not here, but here. An angle of 3 pi over 2 radians. The sine value is -1. So 3 pi over 2 is the other answer to this equation. That was a little itchy. All right, do you feel free to ask questions if you got them? Is pen really good? No, it's pen really good.
Why did you write or?
You're right. It's, I mean, technically it's an or because x can't equal 2 different things at the same time, but you can write and or, it doesn't really matter.
Okay, thank you.
Yeah, you can say x equals pi over 6, 5 pi over 6, and x equals 3 pi over 2. Yeah, it's not there are some times later on where we talk more about and or. Specifically when you take 17C, for those of you that are taking the 17 series, we talk about probabilities, and we talk about the probability of some like thing A and thing B happening versus the probability of thing A or thing B happening. And the difference kind of very, very, very generally is that when you want one thing and another thing to happen, you often multiply the probabilities together. Whereas when you want one thing or another thing to happen, you to find the probability, you add the probabilities together. That is a very, very general statement. It is not 100% always true, but it's kind of the idea behind how that stuff works. So that's when and or start to actually matter. That is also true, yes. Or and also have to do with union versus intersection. So an and is like the intersection of two things. We want A and B, we want the intersection of them where they both are true. Or is like the union, we want A or B, we want the union of them where either one or both of them are true. But yeah, it's not super important right now. It is interesting though that the way we use the word or in English is not the same way we use the word or in mathematics. If someone says, do you want like soup or salad in mathematics, one correct answer would be both. Whereas when we talk in English, the word or we use it actually what's called a mathematical exclusive or, where you want one or the other, but not both. Again, getting off on a tangent, let's get back to the trig with tangents. Like, no, okay, fine. Okay, fine. I knew that wasn't funny before I had said it. Okay. So, plus the next problem doesn't have, it would be way better if the next problem had tangent in it. That would be great, but it's not what's on the practice test. Okay, so this next problem says, write out in words what the following means and then state the answer. Sorry, I'll take the laughs. So I'm actually going to write the answer first because I think writing the answer first might help me better. So the inverse sine of root 2 over 2 is pi over 4. Right, we know we're looking for the angle that you take sine of it, you root 2 over 2. And that's the words we want to write. So the inverse sine of root 2 over 2 means, and you can use, I mean, you do not have to be eloquent here, just as long as you can get the point across. Means we want to find the angle. We want the angle so that sine of that angle is the square root of 2 over 2. That's as specific as you do not need to include the fact that the angle needs to be between 0 and pi over 2, or sorry, negative pi over 2 and pi over 2. You can if you want to. Between, but I don't need you to write that down. That's not super important. I just want you to know that the inverse sine is an inverse function, right? There's this inverse relationship, right? If sine of pi over 4 equals root 2 over 2, inverse sine of root 2 over 2 equals pi over 4. And then a similar thing for a log question. They ask us, what does log, I'm going to pick a different one because we've done this one too many times. Let's do log base 5 of 25. And what does this equal before we write the meaning? Give you a hint, the answer is not 5.
Two.
Exactly. Yeah. So what does log base 5 of 25 mean? So log base 5 of 25 means, or you can also say it's asking us to find the exponent or power with which I'm trying to use like correct grammar. I don't care. To find the power, we raise 5 to get 25. That's the whole gist. And when we see log base 5 of 25, we're like, oh, what power do you put on 5 to get 25? Oh, it's the second power, 5 squared. Yep, good. That's all these questions are asking. Just they really want you to understand the nature of these particular functions, because especially logarithms, inverse trig functions less so, but do come up, but especially in the 17 series, it's a whole lot of logarithms. I mean, it's not true. In the 17, 16, and 21 series, you will see logarithms, but especially the 17 series, you really have to use a lot of logarithms and their rules and tools and all sorts of laws. So just be aware of that. I think we might have already done this. Inverse cosine of -1/2. Just want us to evaluate it. That's going to be the angle whose cosine is -1/2. So that's going to be 2 pi over 3. We definitely talked about that one already when I was solving cosine of x equal to -1/2. So again, this is different than solving cosine x equal to -1/2. This one's only going to be 2π/3, whereas solving cosine of x equal to -1/2 gave us two answers, 2π/3 and 4π/3. And then the next one is also not terrible. I'm going to make it, it's so boring. Fine. Log base 6 of 36 is 2. What if it was log base 6 of 1/36? Then what would the power be? 6 raised to what power is 1/36 going to be? Oh, you're so close. It's not 1/2 though. Yeah, it's negative. So 6 to the -2 is 1/6 squared, which is 1/36. Whereas 36, which is not our base, but 36 to the 1/2 is 6, and 36 to the -1/2 is 1/6. Something that's useful to know about powers in general. Negative powers give you things that are less than 1 typically, whereas fractional powers just typically make it smaller. So like when that's not wholly true, so I maybe take it with a grain of salt, but that's kind of the thing I've noticed. Like if you have things like that. So when I take log base 6 of 136, I know I need a negative power so that this base ends up getting to be this smaller 1/36 number. Let's see here. I guess I should stop talking because it is 2:23. So we will finish.